Hi, Ahava. I want to do a little review today. I have some things on the paper. Point A, represented by point A. Line segment BC has two endpoints, written this way, BC. We have ray DE. Notice that when I write ray DE, that D is the endpoint. I could also write this as ray ED, and I could have, as long as I have the arrow pointing this way, so that the end point is at D. And of course we know that 2 points determine a line. I could name this line line FG, or we can name lines with lowercase cursive letters, which would make this line L. Now I drew an angle. I drew angle angle BAD. And there's three different ways to name an angle. An angle is the intersection of two rays with a common vertex. So the vertex here is point A. And we could name this angle, angle A. But we can also name angles with three letters. This could be angle BAD or angle DAB. Either would be acceptable. Now, we usually use one letter if there's no confusion, but if we need three letters, we have to be sure that the vertex is the middle letter. Now today I want to talk about constructing an angle congruent to angle BAD. And we know that for construction we use two tools. We use the straight edge and we use the compass. Now I'm going to use this for my straight edge today. I'm going to draw a line segment, or in this case I think I'll draw a ray. And I'm going to let my end point be O. So I could make an angle here of any size by using another ray, but I want to construct an angle congruent to angle BAD. So the first thing that I'm going to do is I'm going to cut an arc on angle BAD. I'm going to take my point and I'm going to put that on point A, and I'm going to move my compass until I can get able to connect an arc. I'm going to draw an arc that cuts across angle BAD. Now we know by congruent line segments that this line segment is congruent to this line segment. I'm going to come down here to point O and I'm going to draw an arc. And I'm going to call this point where these two lines intersect point G. So I know that line segment OG is the same distance as line segment AO. Let's call this AF. Call this point F. We know that we measure line segments with our compass, and so I measure that AF is the same as OG. Now, my question that I have to be concerned about is where to draw my other ray. So to do that, I'm going to measure the arc that comes up here from E to F. Point F. Remember, two lines intersect in a point. So I have an arc that goes from E to F, and I need to measure E to F, and we measure line segments with our compass. And my compass is open too far, so I'm going to have to draw it in some. That's what I'm doing right now. I'm drawing in my compass some, trying to make it smaller. I want to be able to put my point, my sharp point at E and my pencil point at F. And so I'm going to, well, it's not quite small enough. Let's go in just a little bit more. If I'm going to measure from E to F, this needs to go right through point F. Okay, that goes through point F. So the distance from E to F will be the same distance I will get if I will come down here and cut an arc going from G, and I'm going to call this point point H. So now I have 2 points that determine a line. I can draw the line segment. You can tell I'm using a different sheet of paper. But I'm going to draw a line segment from O to H. And I'm going to go beyond that and make this into a ray, because we know that 2 rays with a common vertex make an angle. So now I have angle O, or we could call it angle HOG, or angle GOH. And this angle should be congruent to that angle. And so we would write it this way, that angle A is congruent to angle O. Or I could have said angle BAD is congruent to angle O, or I could use any one of the 3 names to do that. But what I have done is I have constructed angle A congruent to angle O. Now, if we take our compass, we can measure to see what the measure of these angles would be. So I'm going to put my compass point at the vertex. My protractor. I'm going to put my protractor at the vertex, and I'm going to line up this side with the line down here. And this appears to be a 45-degree angle. Let's measure this angle. If I put the protractor at the vertex and I line up this side, this too appears to be a 45-degree angle. And it should be. Now, we constructed it to be congruent. We measured it, but that's not a construction when we measure it. But we would say that the measure of angle A equals the measure of angle 0. Notice the difference. Angles are congruent. Measures are equal. Now I'm going to move this piece of paper because I did this before when I was doing things upside down. And I constructed angle RST, and then I drew angle RST, and then I constructed congruent to it angle HIG. And both of these measured 44 degrees. If you construct 2 angles, you draw one, you construct one congruent to it, then you should be able to take your protractor and measure, and they should be the same measurement. This may take a little practice, so practice that now.